Okay, for this video, I'm just going to show you all the basic statistics that you've seen in the notes, how we can get those measures from Microsoft Excel. So what I have here is the data set from the slides, the one that was made up, kind of representative of test grades. It's going to be a single column in Excel. If we're going to think about our data sets as tables, then the instances are the rows in the table, and then all the values for one feature or a column. With these basic statistical measures, we don't ever want to mix different features up. So we would always be applying these one column at a time. If we have three numerical features in the data set, then we'd have three different columns of values. And for all three of those columns, we would calculate the mean, median, mode, standard deviation, variance, and so on. So I made a little cheat sheet for the functions we're going to use in Excel. One's called average for the mean, median and mode exactly the same. STDEV for standard deviation. I always forget that. I always think it has two D's in it, but it doesn't. Oh well. And then the variance is VAR-P. The P stands for population. This just means that we're going to use all the data as opposed to a subset of the data to calculate the variance. So if we want to use any of these, every one of these functions expects us to give it the range of the data. So this video is assuming you're new to Excel. Some of you can skip this video because it's going to be old news. But for those of you that are new to Excel, if we want to give a range, we have to give a starting cell and an ending cell. That's definitely the easiest way to do that. There's more than one way to select a range. You can use the mouse, but I tend to type it in. I give it the starting cell, which in this case is B2, and then a colon tells it there's a range coming, and then we give it the ending cell, B16. Then I close the parentheses for the average function, hit return, and I'm good to go. There's the average. So we can do the same thing. I'm starting these off with equals, although plus sign works just as well. It tells Excel there's a formula coming. So to calculate the median, I use the median function, give it the same range of data, B2 to B16. Likewise for the mode function, B2 to B16. Standard deviation, the one I have trouble remembering, but it wants the same range. For the variance, we're using the whole population, so we give it, once again, the same range. So VAR-P, and then B2 to B16. So now I have all these numbers. The standard deviation here and the variance are about the same. If we square the standard deviation, 16 squared, we're going to get 256. The variance is not 256, it's 247. So what's going on is that the standard deviation and the variance are being normalized just a little bit differently. One of them, they're dividing by n, the number of instances in the data set. One of them, they're dividing by n minus 1. This was kind of glossed over in the notes because as the number of instances gets bigger, or as the statistical measures become more and more useful and valid, then n and n minus 1 are basically the same thing. And you would get the standard deviation to a very good approximation as the square root of the variance. So these are the basic built-in functions that we have to deal with. The last thing I want to do is calculate the z-score. For that, Excel, as far as I know, doesn't give us a nice built-in function for it. So we have to work from scratch with the definition of the z-score, that we want to take the value from the data set, the instance, and we need to know its deviation from the mean. So how far is it from the mean? The mean's way down here in cell B17, so I put that in. And then we have to divide by the standard deviation. That's down in cell B20. So we put in a formula that looks like this, in parentheses B2 minus B17, the deviation from the mean, and then divide by the standard deviation. So we get about 0.6. It's positive, so that means the value in our data set's above average. If it was negative, it would be below average. And it's about 0.6 times the standard deviation. So 0.6 times 16 is about 9.5, and that's about exactly how far our data set is from the average. So now if I want to paste this in to get the z-scores for everything, I can do that. Those of you that know Excel pretty well know that this is not going to work, but I'm trying to illustrate that. We get a bunch of bad formulas here. What's going on? If we look at the formula for the next instance, it's shifted all the cells down by 1, which makes sense because we're moving down the column C, just like we moved down column B with the formula. So Excel added 1. It moved every cell we were referring to down by 1. But we only want to do that with the B3 cell, with our actual data. We always want to use the average. We always want to use the value that's in cell B17. So what we do is we put a dollar sign in front of the B, which means don't shift columns when you're doing this. We put a dollar sign in front of B17. So that tells Excel, treat this cell as a constant. Don't shift it around. We want to do the same thing with the standard deviation, that we want to use not cell B21, but cell B20. And then we want to tell Excel, don't shift this thing around. So we could get away with just the $1 sign. Don't shift the rows around, but it's a good practice if we want to hold the cell fixed to put it for both of them. There's less likelihood that we'll confuse ourselves and do something bad. So when I fix the formula this way, I actually have something that works that I can paste everywhere else, and then I can get all the z-scores. If I want to see what we've done, if I want to look at the average for the z-scores, same function we used before, average, but we want C2 to C16. We want column C instead of column B. So the average is 0. That means we're averaging over deviations. There's just as much above average as there is below average. That's going to be true of any data set we do this with. That is all.